Alright, so in this video we're going to understand how information travels wirelessly. And what I mean by this is that we're going to understand how devices like Wi-Fi, wireless internet, work, how things like radios, say in cars, work, and how things like cell phones, which definitely use wireless communication, how they work. And the reason that we can understand all these in one pretty short video is that they all use the same principle of communication, and they all use communication via waves. So, waves are something that we're all intimately familiar with. We know, from childhood that if we have, say, a lake, and someone throws a rock into this lake, then the rock is going to cause ripples to form in the lake. And the key point about these ripples, what makes them called waves, is that they move, they propagate. And because they propagate, they can carry information out about the initial disturbance that created them. For example, the way that you're listening to my voice right now is that your speaker, this is a very poor drawing of a speaker, but your speaker is moving, and your speaker is creating sound waves. And what a sound wave is just regions of high and low density in the air. These are supposed to be air molecules. And so these sound waves reach your ear, and your ear does some complicated process to transcribe that into sound. But again, these waves, this information transmission is possible because the waves propagate. Now, to understand how all of these devices work, we're going to have to talk about something called electromagnetic, or EM, waves. And the exact nature of these waves is too complicated to go into now, and it's not important for understanding this, but let me just give you some examples of waves that you already know about that are, in fact, EM waves. So, light, for example, is an electromagnetic wave. Microwaves use electromagnetic waves to heat up food. X-rays, whenever you go to the doctor and you get an X-ray image taken, the waves that form that image are X-rays. And lastly, of course, radio waves are another special type of electromagnetic waves. So, how do we use waves to transmit information? That's what we're going to try to understand now. And before we do that, we need to understand two characteristics of waves, two ways that we can quantify what makes one wave different from another. So, if I consider this wave that I have here, there are two things that I can ask about it. One, I can ask, how large is this wave? And to answer such a question, what I might do is I might simply measure, the difference between the maximum value and the central value, or the equilibrium point. And that is something that we call the amplitude in wave terminology. So let's say that the amplitude is A. So this distance is A, and obviously this distance is A. And the difference between the peak and the trough, called the peak-to-peak distance, is equal to, obviously, 2 times the amplitude, or 2a. So amplitude is a very easy, very intuitive concept about how to characterize how big a wave is. So the other concept that's important is called frequency. And frequency is just the answer to the question, how fast do cycles of the wave go by? So by a cycle, I mean a region like this of a wave. The basic unit of the wave that repeats, each one of these is a cycle, and basically frequency is equal to the number of cycles that occur in a unit time, let's say a second. So a wave that looks like this has a much higher frequency than a wave that looks like this, even though they have the same amplitude. So now that we understand what frequency and amplitude mean, we can use these concepts to transmit information. And the first way that I'm going to tell you about how to do this is called amplitude modulation. And this is what the AM stands for in AM radio. So the basic idea is best seen by this example. So say I have some signal, maybe it's a sound signal or something else. Say I have some signal that I want to send you, and that signal looks like this. So how do I send you this signal? Well, just for convenience, you'll see why I do this in a second, but I want to draw the negative of the signal. So this is the signal that I want to send you, and I want to send it to you via an electromagnetic wave. So what I do is I send you a wave of a particular frequency, and I tell you to look for waves of that frequency. What I'm going to do is I'm going to send you this wave where I change the wave based on the signal that I want to send you. So wherever the signal is low, I make the amplitude of my wave low, and wherever the signal is high, I make the amplitude of my wave high. So here we have two distinct pieces. This is the signal, and this wave that I'm sending you is called the carrier wave because it carries the signal. So to decode this, all you have to do is you have to look at how big the wave is at any given point, and then you can get the signal that I was trying to send you. So this scheme is called amplitude modulation, and it's the one that's used in radios most often, AM radio specifically, to get you the songs you hear, say, in a car when you're driving and you're listening to the radio. Now, there's AM and there's also FM, and you've probably guessed by now that FM means frequency modulation. So frequency modulation is another way I can send you information, and of course we can use frequency modulation in the same way that I used amplitude modulation to send you some like sound file. But what I want to talk about now is how, say, things like cell phones use frequency modulation to send digital information. And what I mean by that is that cell phones want to send to each other, or to wireless towers that communicate with them, they want to send information in the forms of ones and zeros. And later they transmit, some hardware on the cell phone translate those ones and zeros into text or sounds or whatever. But to do that, what we can simply do is we can agree that if you're a cell phone and you receive a frequency that looks like this, then you call that a 0. But if you receive a frequency that looks like this, then you call that a 1. So if I want to send someone the message 1 0 1 1, all I do is I send them this signal in which I change the frequency. So I want to send a 1 first. So here's a 1. Then I want to send a 0. Then I'll send another 1. So I have a low frequency. And then I want to send another 1. So to decode this message, all you have to do is you have to look at different points and you have to see, okay, what's the frequency here? Is it a 0 or is it a 1? And so this idea, FM, is the basis of how digital communication takes place wirely. It's actually called something more complex, frequency shift keying. So these two concepts that I've outlined for you guys, FM and AM, constitute the majority of how information is traveled by electromagnetic waves between wireless devices.